Hey guys, welcome back to new video, and in this video I'm going to show you how you can use paging 3 library in your Kotlin multi-platform projects. So first thing, what is pagination? Let's say you want to fetch information from the backend that has a big bulky object that contains list of 1000 items in it, and when you send this bulky object at once to your front end performance will hit very badly, and also it will take a lot of time to process. So instead of sending this bulky object at once, we'll create a small chunks of data. That chunks contain, let's say, 10 items, 20 items, and when you send this information in a form of chunk from your backend to front end, this process is called pagination. And in order to do this process on front end or in Android, we will use paging 3 library. So let's see how we can use paging 3 library in our Kotlin multi-platform projects. So for that, first thing first, go to my GitHub repository, download the project and open up into your Android Studio. This project contains all of the dependencies that will require in order to integrate paging 3 API. So open up your shared module build.gradle.kts. On the top, we have few plugins like KSP plugin and observable KMP view model. This plugin is actually used to expose your state flows very easily in both platforms, iOS and Android. Scroll down, we have Android main dependency that contains two types of dependency, Ktor client and coin dependency and JSON framework dependency. In the common main, we have coin dependency, Ktor client dependency, some lifecycle dependency, and we have the most important thing, paging dependency. We have KMP observable view model. This view model is used to expose your view model in a form of observable object in iOS platform. We'll see what is the use case of this, but for the time being, just be with me. In iOS main, I have added two dependency. First dependency is Ktor client for iOS, and second is Ktor client Darwin. So we are pretty much done with the setup. Now it's time to jump in our Android app Gradle file. And here I have added dependency for coin and the paging dependency. Okay, sync your project, and now we will begin with our paging 3 API. So in order to integrate paging 3 API, we'll require, of course, a REST API. So I'm going to show you that REST API first. So this is our endpoint, and this is the website that contains our API endpoint. Click on this explore and open up your API. It will eventually show you this user interface. Scroll down, we'll have our base URL and we have parameters. This is our API key. Scroll down and just open this link in a new tab. So I did this thing. This is our endpoint, so I'm going to copy this endpoint, and first thing first, I'm going to create Ktor client. So for that, open up your shared module source, common main, and in this common main I'm going to create a package, and the package name is client, and in this client I'm going to create a class, and the class name is Ktor client. In this class we have a function name is get client, and it will return you HTTP client. So return HTTP client, make sure to use that has a pair of parentheses, or you can say trailing lambda. In this, first I'm gonna install my content negotiation, and will use JSON in order to negotiate our content from backend to front end. And you can also add some extra functionality to your JSON by using this JSON object, and in this I'm gonna include ignore unknown keys to true. This is my first installation. Next, I want to install my HTTP timeouts. We have socket timeout in millis, which is 3 seconds. We have request timeout millis, which is of course 3 seconds, and lastly we have connection timeout in millis, which is of course of 3 seconds. Now I'm gonna install default request. So this default request will contain information about the host, about the protocol that will consume, and the content type. So for that, we'll use here a URL closer, and in this URL closer I'm gonna mention my host. So just paste your API endpoint, and this is our host. Just comment this thing out, pixabay.com. This is our host. Copy and paste in here. Next we have protocol. As you can see, protocol is HTTPS. Here you can see. And lastly, the content type. So in the content type, I'm gonna use content type dot application dot JSON. So this is our default request, and we are pretty much done with our HTTP client. So this function will return you HTTP client. Now I'm gonna write one more function which is actually used to perform network request call. So for that, we have, this is not a normal function, it's a suspendable function, get images, and just paste the endpoint. So in this endpoint we have few parameters. First we have key, then we have our actual query queue, and lastly the page, current page, and the per page. So let's pass this thing in a form of parameter. So we have per page information and the current page information. Use get client, so it will give you a HTTP client. In this we're gonna perform get request. Now it's time to complete our URL. So first we have path. Path is API slash. Let me import this path. Next we have to add few parameters. So first parameter is of course our page. Pass your page. Next parameter is per underscore page. Pass your per page. And lastly the actual query. So we have queue and pass your query. Now this will have a body. So use here dot body, and this body will actually return you this response that we have seen. So copy this response and come back to your project and create a model classes corresponding to this JSON. So model, right click, new, use Kotlin data class file from JSON, paste your JSON, and I'm gonna call this Pixabay response. Enter. So this is our Pixabay response that contains list of it. Hit contains all of our information related to that image. So we are interested only in two parameters. First is ID and next is large image URL. Rest of things I'm gonna remove it. And make sure to annotate this data class with serializable, otherwise during the conversion of JSON object into your model classes it will crash your application. Go to your Pixabay response and make sure to add serializable annotation in here too. Okay, so now it's time to use this thing. Come back to your Ktor client, and in this body I'm gonna use Pixabay response and change the return type of our function too, which is Pixabay response. Make sure this is present in the same line. Okay, so we have a function naming get images, which is actually used to communicate with our backend. Now it's time to create a paging source. Now paging source is a central point which is actually used to write a logic and perform network request call to get information depending on the page information. So for that I'm going to create a new package and call this paging source. And in this paging source I'm having a class, and the class name is image paging source. This class will eventually use our paging source. We have here key value. So key is integer and value is hit, because we are dealing with a list of hits. In this we have to override two functions. First is get refresh key and second is load. In the get refresh key I'm gonna use its state anchor position, and in this load we're gonna write all of the logic that is actually used to communicate with our backend. Because there are some network request call going on in this particular function, I'm gonna use here try catch in order to catch any kind of exception. And if you catch any type of exception, we'll simply return a load result dot error. As you can see, return type of this function is load result. In this error I'm gonna pass the exception. Now here I'm gonna create a variable naming response, and in this response we're gonna store the incoming response from our backend API. So in order to use our backend API, make sure to use here Ktor client and also pass your query. Now use your Ktor client dot get images. Just specify all of the argument that we have in this get images function. So we have our query, simply pass it. We have per page and page information. So first let's fetch the per page. Per page and page information is provided by this parameter. So use this parameter, and we have load size. Next we have the current page information, which is coming from params.key, and if it is null simply use 1. Now in the per page you can pass your per page, in the page you can pass your current page. Now I'm gonna return here load result dot page, and in this page we have three parameters. First we have to pass the data. So data is coming from a response dot hits. Next we have to calculate our next key and the previous key. So for the next key we'll check if our response dot hit is empty, that means we are at the end of our pagination. At that case I'm gonna use here null, else I'm gonna use my current page. Because we want the next key, simply add, so +1. In the previous key we have to check the page number. If page number is 1, that means we are currently standing on the first page and we don't have any kind of previous page. So pass null, otherwise you can use your page and -1 in it, so it will give you the previous key, and at the end use a return in front of your try. So this is what image paging source is. Now it's time to use this image paging source in our repository. So for that, let me create a package, and the package name is repository. In this repository, I'm going to create a class, and the class name is image repository. This is a class, and in this class I'm going to use my Ktor client as a dependency. This will have a function, and the function name is again get images. So we have to pass our query. Now in this we have pager, and this pager have the configuration and also our image paging source. So first let's define the configuration regarding to our paging source. So for that, we'll create an object of our paging source, and in this you can pass your page size, so which is 10, enable placeholder which is true, and prefetch distance is 1. Next we have to mention our paging source factory. So just press command P and it will show you the initial key and the paging source factory. So I'm going to use here paging source factory, and in this pair of parentheses I'm going to use my image paging source, and the requirement of image paging source is Ktor client and query. So pass your Ktor client and the query. Check the return type of this pager. So it will return you pager. Key is integer, value is hit. Now I want to convert this thing into flow so that we can consume it very easily in our view model. So just use .flow, and now it will become something like flow of paging data, type is hit. Now I want to return it. So for that, change the return type from nothing to flow of paging data hit. Import this hit and return it. So we have our image repository. So we are pretty much done with our image repository. Now it's time to create our view model. So for that, in this image search package, I'm going to create a new package and call this view model. And in this view model, I'm going to create a class, and the class name is image view model. This class extend view model, and make sure you'll use a view model which is coming from observable view model. In this we have private variable naming query, which actually holds the query. Mutable state flow, make sure this mutable state flow is also coming from observable view model dot mutable state flow. And in this we have to pass our view model scope and the initial value. Now we have a variable naming images, and this images is actually exposed to our Android app, and our Android app will simply consume it. So we have here query, and we're gonna filter it out. If it is not empty, and we're gonna introduce some throttle of 1 second, then we're gonna consume the query. And in this query we'll use our repository. So in order to use repository, first just use here coin component and create a variable naming a repository. Type of this thing is image repository, and inject it lazily. Now use repository dot get images function and pass your query. Now this will, as you can see, it will give you flow of paging data, type is hit, and I want to cache this information in my view model. Because I'm using here observable view model library view model, due to that reason we have to pass view model scope dot its coroutine scope. Alright, so we are pretty much done for Android. Now it's time to expose all of the information for iOS. So to do that, I'm gonna create a data class, and we have here iOS UI state. In this we have few variables, like we have is refresh, type of this thing is boolean and initial value is false. Next we have is append, boolean false, and lastly we have prepend, type is boolean and initial value is false. So this iOS UI state is actually used to tell our iOS application what is the state. I mean, we are in the refresh state or append state or prepend state. So the sole purpose of this thing is to give the update to our iOS application. Okay, so now I'm gonna create a private variable presenter and initialize this thing with object of paging data presenter. Type of this thing is hit. simply import your hit, and in this we have a function. Simply press Ctrl I and override it. Present paging data event. Just below to it, I'm gonna create one more variable which is item snapshot. It's a mutable state flow of type item snapshot list that contains hit, and we have to pass here view model scope, and its initial value is coming from our presenter.snapshot. So this item snapshot is actually consumed by our iOS application. So if you want to expose this item snapshot, you'll use here native coroutine states. Next, I'm going to create a function update item snapshot, and in this function I'm going to update my item snapshot value with presenter.snapshot, and simply call this function within your present paging data event. So update your item snapshot, and we'll require one more function which is actually used to get element from our item snapshot, and I'm going to call this get element, pass your index. A return type of this thing is hit, so use your presenter dot get and pass the index, so it will provide you hit corresponding to this index. Okay, so we are pretty much done with our item snapshot. Now it's time to create mutable state flow for iOS UI state, so that our iOS application will consume this iOS UI state very easily. So for that, I'm going to create here two iOS UI state mutable state flow. So mutable state flow, pass your view model scope and the initial value which is iOS UI state. Next we have iOS UI state. Use your iOS UI state and convert this thing in form of state flow, and use native coroutine state because I want to expose this thing. Now it's time to update our iOS UI state based on the presenter load type. So for that, at the bottom I'm gonna create here init block, and in this init block I'm gonna launch a new coroutine using view model scope. In this we'll use presenter, and we have a load state flow. We'll check if it is not null, then I'm gonna collect, and in this collect we are receiving the state, and after that I'm simply updating my iOS UI state. So we have iOS UI state in this that contains 3 parameters, so specify all the remaining argument. We have is refresh, is append, and is prepend. So for the is refresh we'll use state dot refresh, and if it is a type of load state dot loading, that means yes, it is a loading case, otherwise it will give you false. Similarly for the append, I'm using state dot append, load state is loading, and lastly for the prepend, so state dot prepend is load state loading, and that's it. So it will update our underscore iOS UI state, and by using this iOS UI state we can consume the current value in our iOS platform. Alright, so now it's time to update our presenter with the new incoming value which is coming in our images. So for that, again in this init I'm gonna use view model scope and launch a new coroutine images dot collect the latest emission, and it will provide you I'm gonna call this local images. Use your presenter and collect from local images, so it will update your presenter. And I want to put this thing within a function so that we don't execute this flow unnecessary, so that we cannot execute this block again and again when we initialize our view model. So for that I'm going to cut this thing out and create a function init iOS presenter and put this thing in here. Alright, so yeah, we are pretty much done with our view model. So these images will be used by our Android app, and this item snapshot will be used by our iOS application. And this iOS UI state contains the information regarding the append, prepend, and refresh. We are pretty much done with our view model. Now it's time to set up co-dependency injection framework for our project. So for that, in this image search app I'm going to create a package naming dependency injection, and in this I'm going to create a file. and the file name is shared module. That has a variable, and the variable name is shared module. We have a module in it. We're going to create a factory that has our image repository, and the requirement of image repository is Ktor client. So on the top, just create one Ktor client object and simply use getInit. Now it's time to provide our view model. So in order to provide view model, in this DI I'm going to create one more file and call this view model module. In order to provide modules, we have different approach for Android and iOS. So for that I'm going to create a expect variable view model module, and type of this thing is module. It's time to provide actual declaration for this view model module in both Android main and iOS main. So we are pointing in our iOS main. So for the iOS, I'm going to create a module single and create an object of our view model, which is image view model. Just below to it, I'm going to create an object, and the object name is shared view model module, and use your coin component. In this we have a function get image view model. Return type of this thing is image view model, and use here get. Make sure this get is coming from your coin library. Okay, so we are done with our iOS. Now it's time to give the declaration for our Android main view model module. So remove this get and use here module, and in this module we have view model, and in this view model, so basically I'm using here view model of import it, and in this I'm gonna pass my image view model. Okay, so use here 2 colon. Alright, so now it's time to attach these modules in our platform. So first let's do for Android. So for the Android, in your Android main, we have to create a base application and extend this base application with application. Make sure this application is coming from android.app. We have on create, and in this on create just call start coin and attach all of your modules. So we have 2 modules, shared module and view model module. Now register this base application in your manifest. So Android app, Android manifest, and in this application just register your base application, and on the top make sure to take permission for internet. Alright, so now it's time to set up DI for iOS. So go to your iOS main, and in this iOS main I'm going to create a file, and the file name is setup coin. We have a function, and the function name is init coin. Use start coin modules and register your shared module and view model module. Let's begin our journey with Android user interface. So for that, go to your main activity, and before writing anything in here, I want to add one more dependency in my build.glad.kts. We have here implementation libs. We have paging compose.common. Sync your project. Open up your main activity, and in this main activity remove these greeting things. Now first thing first, I want to create my image view model. So view model will be initialized with the help of coin view model. Mention the type, which is image view model. Now in this surface, I'm going to use my images which is present in our view model. Use your view model dot images and collect this thing in a form of lazy paging item. Next, I'm going to create one more variable which is actually used to hold our user query. So variable query, this is a state. So remember savable mutable state of empty string, import it. Alright, so now it's time to begin with our UI. So I'm using here scaffold, and in this scaffold we have top bar. So this top bar will actually contain a text field where user can enter its query. So we have text field, and in its value we will pass our query, and if anything got changed in this text field, we want to simply update our query with the help of incoming values. And one more thing, I have created a function in my image view model. update query. So this is actually used to update our query mutable state flow. Come back to your main activity, and in this I'm using my view model update query and pass your query in it. Next, I want to change the colors of my text field. So use here text field default dot colors, and in this color we have unfocused indicator color, which is nothing but transparent. Next we have focused indicator color, which is also transparent. And lastly we have modifier fill max width. So that's it for our input text field. Now it's time to use lazy column, and in this lazy column we have modifier padding, which is coming from our scaffold trailing lambda, fill max size. Now in this lazy column we'll use items, and in this item we'll pass the item count first, which is coming from our images dot item count. Next the key, images dot item key, and I'm using my id as a key. In this lambda we'll receive the indexes, and by using our images dot get will get the actual image. Now we'll use here async image. This async image is coming from coil library, and I think I haven't added this thing in my build.gl.kts, so let's add it. Implementation lips coil.compose, sync your project and come back to your main activity. Okay, so now it is available. In this model you can pass your image URL, so image dot large image URL. Okay, so this may be null, so I'm using here image dot let op scope function, and in this I want to put my async image. Now it is not nullable. Next we have content description, which is null. We have modifier fill max width, and its height is 300 dp. Import this dp. Next we have content scale, which is crop, and also I want a little padding from top and the bottom. So to do that, just use here padding vertical of let's say 4 dp. Alright, so we are pretty much done with our Android user interface, but now it is time to add all of the load state that we were having in this paging states. So for that I want to check few things. If our images dot load state is a prepend, and it is a type of load state dot loading. In this case I want to create a box having modifier fill max width, and its height is 55 dp, and content alignment is on the center, and in this we'll use circular progress indicator. By the way, this box is composable, and we can only invoke composable function within a composable scope. So to create a composable scope we'll use here item, and simply cut this thing from here and paste within our item. So this is for the prepend. Now similarly we have one more state for append. So instead of prepend, now it will become append. Okay, now what will happen if we receive any kind of error? So for that we have images dot load state append. If it is a type of load state dot error, on this occasion I'm going to create an item having box modifier fill max width, and its height is 55 dp, and my content alignment is on the center. That contain a button. Okay, and in this button UI, let me make some space for you, and in this button UI you have a text, and it text says retry, and in its on click we'll simply use our images and perform the retry event. Similarly goes for the prepend. So copy this and paste on the top. So if it is a type of prepend and we have error, on that occasion we can perform the retry operation, and this retry is smart enough to know in which state you are receiving this error. Okay, so yes, we are done with the prepend state and the append state. Now it's time to see how we can use a refresh state. So for that, here on the top, I check our images dot load state is refresh. If it is a loading case, that means load state dot loading. On that scenario, I'm using box which has a modifier fill max size and its content alignment is on the center that contain a circular progress indicator. Okay, and if our refresh is not loading on that occasion, we are showing this lazy column. Or to be more specific, what I can do, I can also check the refresh is error or not. If it is not error, then we will show this lazy column. So basically, if refresh state is not loading and also it is not the case of error, then only will show the lazy column. So instead of else, I am removing this else from here and write one more condition. Images dot load state refresh is load state dot error. If it is error, then using box having modifier fill max size content alignment is on the center, and in this I want to introduce a button, and in its UI we have a text which says refresh, and in this button on click we'll use our images dot refresh. Alright, so now when we show this lazy column, well, we'll show lazy column if our images dot load state dot refresh is not of type load state dot loading and images dot load state dot refresh is not a type of load state dot error, then only we'll see this lazy column. Alright, so that's it for our state management in Android. Now I want to execute this application to show you how it is working. But before that I have a problem, and okay, so it's nothing. Execute it. Okay, so we are seeing this circular progress indicator because of refresh state. So let me show you that refresh state. Okay, here you can see. So images dot load state dot refresh is loading. And also we have to write one more condition, and our query is not empty, then only we'll show this. Okay, this time it is not visible, and in this I want to search yellow. Alright, so we have a problem, and I think this is related to our API endpoint. So let me see the problem. To fix this issue, go to your Ktor client, and in this Ktor client I have missed a slash in front of my API, and also I haven't attached my API key. So let's add this API key too. Cut this API key from here and paste in this. One more thing, in your build.glide.kts we have to add one more dependency which is related to OKHTTP. So implementation lips coil. As you can see, in this we have network OKHTTP because this coil image loading library under the hood uses OKHTTP. That's why you have to add these dependencies too. Sync your project, open your main activity, and I think we are good to go. Execute it. Now I will type here yellow. Okay, so as you can see, we are receiving the image. Scroll down. Just to show you the append and prepend state, what I will do, I will add some delay in my image paging source. So after this response, I want to introduce delay of, let's say, 3 seconds and re-execute our application. Now I'm typing here hello yellow. Okay, scroll down. As you can see, this is our append state. Okay, when you scroll up, surely you will see prepend state, but that is somehow not possible because it is already been cached in our memory. Due to that reason, in prepend it's sometimes not possible to show you, but yeah, it was there. Okay, so that's it for Android. Now we'll continue with iOS app. We have to set up coin dependency injection framework. To do that, go to your iOS app.swift, and in this I'm gonna import my shared module in here, and after that in its init block we'll use setup coin kt.doInit coin. So coin dependency injection is now available in our iOS application. It's time to begin with our user interface. So in order to write our user interface, first thing first, we require our view model. So we'll get that view model by using state view model annotation, but this annotation is not available because we haven't added the dependencies for the KMP observable view model and the native Kotlin scopes in our iOS project. So let's add that first. So to do that, I'm gonna show you the GitHub repository of those observable library. So this is our KMP observable view model, and we have to install this package in our iOS app. As you scroll down here, you can see Swift section. We have add it in Xcode by going file, add packages, and providing the URL. So simply copy this URL and come back to your project. As it says, file, add packages, and search for the package. So simply paste the copied link, and this is our KMP observable view model. Add package, add it. Okay, so this is for the KMP observable view model. Next we have native coroutine, and when you see the Swift section, we have add it in Xcode by going file, add packages, and providing the URL. So simply copy this URL, come back to your Xcode, again go to file, add packages or dependencies, simply paste your URL and click on add packages and add it. Okay, so now state view model is available, but for that we have to import the module in here. So we have KMP observable view model Swift UI. As you can see, now it is available. So we'll use our view model by using shared view model module dot shared dot get image view model. So this will initialize our view model in state view model. Okay, so we have a problem, and the problem says, all right, so as you can see in this KMP observable GitHub repository, we have some basic setup that we have to do. This is the setup. So simply copy this stuff, come back to your Xcode, not Android Studio, and I'm going to create a new group. Group means package in iOS, and call this view model, and in this view model I'm going to create a file. This is a normal Swift file, and I will call this KMP observable view model for iOS, and in this I'm going to paste it. Okay, now go back to your content view, and as you can see, the error is gone. Okay, so we are pretty much done with the basic setup. Now it's time to begin with our user interface. So I require a state. So state is nothing but a private variable, naming is search query. Initialize this thing with empty string, and now it's time to begin with our user interface. So remove this text, and we'll use here Z-stack. And in this Z-stack, first we'll handle all of the states that we have in our pagination. So to do that, I'm having a list, and in this list we have section. Now in this section, first I'll check my view model iOS UI state dot is prepend. If it is true, on that case I'm gonna show a progress view. Okay, and make sure this progress view is wrapped within a H-stack. H-stack means row. We'll use here spacer and put this progress view in between this spacer, and also I want to give some height and width through my H-stack. So for that we'll use frame, and its max width is infinity and its height is 55. Okay, so this is the height, so use here height. And yeah, that's it. This is our progress view for prepend. Similarly, we have to create one more section, and this time we'll show the append state. So if our view model iOS UI state dot is append, on that scenario I'm using the same user interface. So simply copy it and paste in here. Okay, so we have our prepend state and our append state. Now it is time to show the refresh state. So for that, again, I'm gonna use here a condition if view model iOS UI state is refresh, then I'll use here Z stack this time, and in this Z stack we have progress view, and this time we'll use frame of max width is infinity and frame of max height is also infinity. That means our progress view will appear at the center of our screen. Okay, so we have mentioned all of the load states. Now it's time to show the actual list. So for that, if it is not the case of refresh, then only will show the list. Now in this I'm using for each, and in place of data I'm using my view model item snapshot dot indices. And next we have to mention the ID, because in iOS we have to provide the ID. Using this ID it is verifying your list item. So ID is nothing but I'm using myself, and it will give you one by one the index. Okay, so by using this index we'll retrieve the element by using our shared view model function naming get element. So we have let image, and this image is coming from our view model dot get element, and in place of index we have to pass int 32-bit index. Okay, so this will give you the image. Now we'll check if this image is not null, then only we will proceed. So for that we'll use here optional binding. If this is not null, then only we'll proceed. We have here async image, and I'm gonna use async image that has URL, content and the placeholder. So simply press enter. In place of URL you'll use here URL and pass your string. Now this is coming from our image dot large image URL. Next we have content, and in this content we'll retrieving the image that is downloaded by our async image, and I want to perform some resizable operation. That's why I'm using here resizable. Next we have aspect ratio, which is fill. Next I'm going to decide the frame of this. So frame is max width is infinity, and next we are using frame for the height. So height is 300, and at the end simply use clipped so that this all operation will be performed properly, and after that use clipped. That's it for our content. And for the placeholder I'm using Z stack, and in this Z stack we have progress view, and I'm gonna write loading as a text, and of course use here frame. Height is 300, and yeah, that's it for our for each loop. Now it's time to attach a search text field in our screen. So to do that, simply wrap your list, and here in this I'm using navigation title first, which says images, and next we have searchable. So use here searchable, and we require a binding. So already we have created a state naming search query. So in order to convert this state into binding, we'll use a dollar in front of our state and simply pass it. Now if anything got changed in our search text field, we have to hit our update function. So for that we have a function on change of. So on change of our search query, we'll have to perform action, and in this action we'll receive the new value. So using this new value I'm using my view model dot update query function and pass the new value. And as you remembered, we have created a function which is actually used to trigger the collection of our images for presenter. So we have to do that thing too. So on appear I want to perform something, and in this perform function I want to perform my view model dot. Okay, so I think that function is private. So open up your view Android Studio shared code base, This is our shared view model, and we have a function in this naming init iOS presenter. So simply copy it, come back to your project and paste in here. I think there are some collision with this init name. So what I will do, I will remove this init from here and use iOS presenter. Come back to our Xcode and change this from init iOS to iOS presenter. Alright, so this is available, but it is not showing here because we have to rebuild our project. So just use Control B, Command B. Okay, so build is succeeded as you see. Okay, so now we don't have any problem. So in order to show you this navigation title, I'm gonna use navigation stack and put all of your Z stack in this navigation stack. Alright, so I think we are pretty much done with our iOS Swift UI. It is time to execute our application. Okay, so we have our search text field, and in this I want to search yellow. So we have refresh state. As you can see, now we are getting all of the images. Scroll down quickly so that you can see the append state. As you can see, this is our append state. I want to make this progress view on the center. So for that, go to your loading section of your async image, which is in here in the placeholder. Just add frame for max width and use here infinity and re-execute your iOS app. Okay, so again I want to search here yellow. This is our refresh state, and this time as you can see, loading is appearing on the center of our placeholder. Alright, so that's it for this video. I hope you enjoyed a lot. It's a very cool video for those who didn't do pagination in KMP multi-platform projects. So we will meet in our next video where we will discuss something new about KMP or Android. Till that, goodbye.